So with respect to our curriculum, we are going to see simplified instructional computer. So what is a simplified instruction computer, or its abbreviation is SIC? What it means? It is a hypothetical machine. That means it is a fundamental study of any architecture. Before studying any particular architecture, we are going to see the general architecture of the computer, and that's what is called simplified instructional computer. It is a hypothetical machine. Now there are two versions of this SIC. One is standard version, that is SIC machine, and another one is SIC XE version. So this XE stands for extra equipment in some of the books, and some other books it is going to say extra expensive. Okay, so it is a next version of this SIC. Now these two versions are designed to be upward compatible. So SIC stands for simplified instructional computer, and SIC XE stands for SIC along with the extra equipment. Now we are going to see what is SIC machine architecture or the computer. So it is upward compatible, means whichever input, which is the input what you are going to give the SIC program, which will always run on the upper machine also, upward compatible machine also. The same input may run on this machine also. So that is called upward compatible. This SIC machine architecture has any machine, any computer machine or any architecture must have the memory, must have the registers, must have the instructions, must have the addressing modes. All these topics are very important for any machine architecture. So in this case, for this SIC machine, we are going to say it consists of memory, which is 8-bit bytes. Means each information is a 8-bit. That means 8-bit of information, and it consists of so many information which is a 8-bit, pattern of 8-bit. That's what we are going to say. And how you are going to have a word in this architecture? It is having a word which consists of 24 bits. 24 means 8 3s are 24. That means 8 indicates 1 byte. So it is going to have 3 bytes in a word. Any word, any programming language, any program, when you are going to have some words. So that word is represented as 24 words. Okay, 24-bit words. So any word in a SIC machine architecture consists of 3 bytes. That's all. Then there are total number of 32,768 bytes. That means 32 kilobytes of memory it is having, and it has 5 registers, and each register contains the information of 24 bits. So any register in SIC machine consists of 24 bits information. So we have here 5 types of registers. One is A, one is called A, which is an accumulator, and it is denoted by 0. X is index register, which is denoted by 1. L is linkage register, which is denoted by 2. PC, program counter, which is denoted by a number 8. And then we have status word register, which is denoted by 9. Now what are these, what type of information it is going to hold is very important. Whenever you do computation, the result, one of the result will be present in the accumulator. Then whenever you are going to deal with the different locations in the memory, or if you are going to write an array in a assembly language code, then at that time that indexing information is present in the X register. Then you have a linkage register. This linkage register which used to store the return address. Then we have a program counter, is a a register which holds the address of the next machine instruction to be executed, and status word which is having the condition code. What it indicates is whether when you are going to poll a particular device, whether the device is ready or not, that is, it is going to set some condition codes in this register SW. So SW holds condition codes, and whenever you poll a particular device, okay, whether the device is ready or not, device in the sense it may be an input device or output device, whether the device is connected or not, whether the device is ready to accept the input from the environment, or whether the device is ready to output the information. So for that we are going to poll the particular device, and we are going to see whether the device is ready or not. And while polling the device, if the device is ready, then a particular condition code is set in the status word register. If the device is not ready, then in the status word it is going to have a condition code as equals to symbol. If the device is ready, then it is going to have a status word condition code as less than symbol. If the device is not ready, the status word condition code is less than symbol. So this is what we are going to see in the next slides. So first we have seen the memory, and then we are going to see then we have seen the registers. Now we are going to see the data formats. So there are three types of data we are going to have. One is integer. Any integer is stored as a 24-bit binary number, and you can have negative numbers also. So these negative numbers are represented as 2's complement of that number. So any negative number is represented as 2's complement of that number. And we have characters also for this SIC machine, which is represented as 8-bit ASCII codes. Then we do not have floating point data format for SIC machine. So there is no floating point hardware which is present in SIC architecture. Now we are going to see the instruction format. So in this SIC architecture, it has a 24-bit format. 24-bit means 3-byte format. Each instruction is of 3-byte instruction. That's why we also can say 24-bit format. The flag bit X is used to indicate indexed addressing mode. So let us see this instruction format. This has got 3 parts here: opcode part, X, and address. The first opcode part, this is also called operation code, which indicates what type of operation is to be performed by this instruction. That indicates the opcode part. And we have the next part is X, which indicates, that is, if this bit is set equal to 1, then it is indexed addressing. If this bit is not 1, then it is direct addressing. Then we have the third part is address of the operand. So we have 8-bit opcode part, then we have 1 bit for to store the bit X, that is whether it is index addressing or not, and then we are going to have 15-bit address field for the data. So this is the only one type of instruction we have for the SIC architecture. Then we are going to see addressing mode. So there are 2 addressing modes which are available for SIC machine. One is, if the X bit is set equal to 1, then it is indexed addressing mode. If it is not equal to 1, if it is having 0, then it is indicating direct addressing mode. So we are going to see here, if X bit is if X, now in this table you can see the mode direct and indexed. Direct addressing mode, which indicates that X bit is equal to 0, and the target address, what is the target address? Address of the operand. Target address is can be calculated as address whatever is specified in the instruction. Then we have another mode, indexed mode, wherein this X bit is equal to 1 and the target address is calculated as address plus content of the index register. So contents of the index register. So that is what we are going to have for the indexed addressing mode. So we are going to see instruction set. What are the different kinds of instruction set we are going to have for this SIC machine architecture. So as we say that instruction length is 3 bytes, that means it is a format 3 instruction. Each instruction is a format 3 instruction for this SIC machine architecture. There are different kinds of instructions which we have for this architecture. One is load and store register. So load and store register are indicated by the mnemonics or the operations like LDA. LDA stands for load accumulator. LDX stands for load the index register. XTA stands for store the accumulator contents to the particular location. STX indicates that take the contents of the index register and store in a particular location. So there are different kinds of load and store instructions for this SIC machine architecture. Then we have integer arithmetic operation. So in fact we do not have floating point operation, so we have only integer type arithmetic operation. So we have add, subtract, multiplication and division. So these are the 4 basic operations can be performed on this SIC machine architecture. Then we have another instruction called compare instruction. We are going to in this case we are going to compare 2 registers contents or 2 different locations contents. So for that we are going to have compare instruction. And conditional jump instruction, we have conditional jump instruction like JLT, jump less than, then JEQ, jump unequal, JGT, jump greater than. These are the different jump instructions. And all these, remember, all these instructions are 3 byte instruction. Then J sub instruction, what it does is it jumps to the subroutine and it places the return address in the register L, because when you call this particular subroutine, that control will be transferred to the subroutine, but after executing that subroutine, where it has to come back, that address, the return address will be stored in the linkage register, and a special register we have called L register, linkage register in SIC machine architecture. Also, after executing the program, you have to come back to the next instruction where we have after calling the subroutine. So it returns that the return subroutine instruction which jumps to the location which is specified in the linkage register. So after executing the subroutine, the R subroutine or return subroutine takes the address from the linkage register and it resumes the execution of the program. So the next one is IO instructions. So these IO are performed by transferring 1 byte at a time to or from the rightmost bit of register A. So each device is assigned a unique bit code as operand, and we have 3 types of instructions, that is test device TD, then we have read data RD, and write data which is WD. So we have 3 types of input output instructions. Test device. So test device instruction, what it does is it tests the addressed device whether the addressed device is ready or not for sending or receiving the information. So depending on that, it is going to, if the device is ready, then the condition code less than is set. If the device is not ready, then the condition code which is set equals symbol in the status word register. Then we have the next type of instruction, that is read data. Read data reads the data from the input device. Write data, write the result into the output device. So these are the three input output instructions for SIC machine